In this video, we will talk about bubble sort. In bubble sort, there are various number of passes, and what are the pass? You will understand it better when we will discuss the example. And in each pass, one element places to its correct position. Okay, and in each iteration of every pass. We will compare the two adjacent element, and if we will find that they are not in correct order, then we will swap these elements. It is an important operation in the bubble sort. So how the bubble sort work? Let's see it in example. So here it is here the example given. We have these numbers 18, 12, 1, 5, 14, 16, 2, and we wanted to sort it in ascending order. Okay. So initially we have the pointer. Initially we have two pointer here. One is representing the beginning of the array, and one is the ending of the array, up to which we want to sort the array. And okay. So we will start from here and we will compare these two elements, adjacent element 18 and 12, and we will compare this element and we will find that if they are not in correct order, then we will swap them. We will find that 18 and 12, 18 is greater than 12, so 18 should be after 12. So we will swap these two elements and we will find that 12 will come here and 18 will come here. Then and also we will increment the pointer by 1. Okay. So now we will compare 18 and 1, then they will swap again and 1 will be here and 18 will be here. Then we will compare 18 and 5, and then 5 will come here and 18 will come here. And uh, then again we will compare 18 and 14, then 18 will be here and 14 will be here. And when we again then we will compare 18 and 16, then 16 will come here and the 18 will come here. Then again we will compare 18 and 2, and we will find that 2 comes here and 18 comes here. And then at last we will find that 18 is the greatest element in the array. So 18 should be placed at the last if we want to sort them in ascending order. So 18 has been placed to its correct position. So that is the point. That is the second point. It is saying that in each pass, one element places to its correct position. So this is the pass one. This is the pass one. This is called pass one. We will start from here and we will go on until we do not found the end of the array. In this case, in pass number one, end of the array this. Okay. And when pass number one is terminate, and then we will find that 18 is placed to its correct position. So it is already sorted. So now our array that we have to sort is this only. So end of the array pointer will come here at the 2, and the start of the array will here comes here. Okay. Then we will compare the two adjacent element, and then whenever we will find the elements are in incorrect order, then we will swap them. Then again we will compare 12 and 1, and then they will be swapped, and 1 will comes here and 12 will comes here. Then we will compare 12 and 5, then 5 will comes here and the 12 will comes here, and we will do it so on until we do not reach the end of the array pointer. And at this place we will terminate, and this will be the path number 2, and this will be the path number 2. And we have sorted two elements, 16 and 80 has been placed to its correct position, and now we are left with this array only. So now end of the array pointer will be here, and then we will start again, and then we will again compare the two adjacent element, and whenever we will find that they are in not correct order, so we will swap them. And here pass number 3 will be end, pass number 3 will be end, and 14, 16 and 18 will be in correct order. So these elements are sorted, and now we are left with this array. Now again we will compare the two adjacent element, and we will terminate here, and then path number 4 will be here, and then we will find that 16, 14, 18 are sorted, and now we are left with this array. And now we will again do the same thing in path number 5, and here 5 numbers are sorted, and now we are left with two array, two elements only. Now here comes for path number 6. So here 6 element has been sorted, and we are left with one array, and it is already been one element is already been sorted, so we do not need to go to path number 7, but if we want to go, then we can go. Okay, so here we will find that there are in this array there was 7 elements, so pass will be 7. Okay, so pass will be 7, and in pass number 1, how many times we are comparing the elements? 1, 2, 3, 4, 5, and then 6 times. That is, and if we are at the pass number 1, in pass number 1, if there is 7 element, then we are comparing n minus 1 times. Here, in pass number 2, we will compare n minus 2 times. 1, 2, 3, 4, 5. In pass number 3, then n minus 3 times. In pass number 4, n minus 4 times. In pass number 5, n minus 5 times. In pass number 6, n minus 6 times. And in pass number 7, n minus 7 times. And n is 7 here. So we will find what will be the time complexity of this algorithm. That number of the time complexity of the bubble sort will be time complexity time complexity of the bubble sort will be a number of passes into number of comparisons. Okay, so it will be order of n square. It will be order. Here it is the pseudocode in bubble sort. We have given the array and the length of the array. Then we will start the loop from n minus 1. It is representing that in pass number 1, how many comparisons are needed. Okay, so in pass number 1, n minus 1 comparison will be needed. In pass number 2, I will be incremented by 1. So pass number 2, n minus 2 comparison will be needed. In pass number 3, n minus 3, and so on until I is greater than 0. So this loop will be this loop will run for n times and this loop run for I times. So overall time complexity will be order of n square. Now there are many cases in bubble sort. Let's say we are given already a sorted array. For example, we have given 1, 2, 3, 4, 5, 6, 7, 8. We have given this array and we want to apply the bubble sort to this array. So worst case time complexity will be order of n square. Okay, but it is already been sorted. We do not need to sort it. So how can we uh, reduce the worst case time complexity in this case when the array is already sorted? How we can reduce it? We can simply uh, create the check here. For example, let me use another one. Here we will take one variable. Let's say int flag. Int flag is equals to 0. And whenever we will find at least one incorrect order of the elements, then we will what we will do here, one more line will be added that we will set the flag to the 1. And after this loop is terminated. At this point, we will check if flag is equals to 0. Then we'll simply break. Why? Because if flag is 0, it means that we didn't find a single incorrect order incorrect order of the element. It means the elements are already been sorted. So we do not need to go on further passes. Okay. So we can simply break from this loop. So in this case, the time complexity will be order of n, and in order of n, we can terminate the loop. Okay, so we can reduce the worst case time complexity of the sorted array will from order of n square to order of n, but overall time complexity will be order of n square only. Uh, it is a special case when the array is sorted, then we can write the bubble sort which can work in order of n. But if it is but if it is a random array which is not sorted, then the worst case time complexity will be order of n square only. Okay. Then I have written the code. I have written the code in C++ of the bubble sort. Uh, do not focus on this part. This is for the input and output. I am using the Sublime text, so this is uh, this is the code for this. And then if you are running the C++ code on terminal, then you do not have to write this. Okay. So I have taken the vector of this element, and number of element are 7, uh, and we have run the loop. Now here I am printing the array. I have pulled this, and then you can find that array is array is sorted now.